Dear colleagues, I'm glad to meet you at our next webinars of the company Kintech Laboratory, which are devoted to our software tools. My name is Ivan Zaev, and today with me our software will be presented by my colleague Vadim. Okay, let me say just a few words about our company. Our company was established in Moscow, Russia, by researchers from Kurchatov Institute, from Moscow State University, and Moscow Institute of Physics and Technology. And mostly we are doing two things. First one is software development, and second, it is R&D projects with industrial companies and academic organizations. We develop three primary software products. It is KintechDB. It's a database of physico-chemical properties of substances and processes. Second is Chimera. It is a tool for calculation of the microscopic properties of substances and reactions based on first principles data. And our main software, it is Chemical Workbench, which is an integrated environment for development and reduction of the chemical kinetic mechanisms, as well as a conceptual design of chemistry-intensive technological process. Okay, now I will ask Vadim to start the presentation of the KintechDB software.
Thank you, Ivan. First, I will tell about the place of KintechDB in all our software. So this our software is devoted to development of kinetic mechanism, modeling of devices of combustion, propulsion, and so on. And actually, KintechDB is a part of the system which is made for several reasons. First is a collection of various data. Since the modeling may start from actually finding of processes and substances properties, starting from quantum mechanics and finishing to the properties of devices, including transport and other properties. So the number of different figures, data, quite big, so you need sometimes to save electronic properties of substances and thermodynamic, kinetic properties, and sometimes you make collections of data and make chemical mechanisms which can contain some figures which are different from the data that you can find in the reference books. So the number of data is big, so you need to collect it in one place, share, modify, and so on. So this was the first reason to make an extensive database. The other reason was to make an information system. That means that many people can work with the database. The database may be located at the local computer or the small computer, and all the users can have different access rights to this database. So this information system protect your data. So if start changes, if one project ends, another starts, you will never lose any data, and you can continually develop some mechanism for some models. And our reason is to make this data available in different applications, from quantum mechanical ones to just flow dynamics, using flow dynamics, and sure kinetic one. So data import and export is very important. So you need to be able to read any formats and to export your data to any format that is mostly in use in modern science. And also, maybe the last reason is to make the work with the data comfortable, so you can find any information in your database very easily with our software. You can visualize, plot, and make the data in the table format to just use the reference or to analyze it. And also, database contains several useful tools for data analysis, for mechanism comparison. This make the work with the data quite easy and successful, useful. So the data in the database one has set already, so it contains the thermochemical properties of substances, atomic, molecular properties, the properties elementary processes like chemical, sure, optical, plasma chemical, also interaction potentials, and the complete set of substances and reactions which are called chemical mechanisms. So as I said, the KintechDB is an integration and information system which join or connect the different levels of data from quantum chemistry, microkinetics, chemical kinetics, and support and supply the data to the applied software like CVD and Keyfluent and so on. Currently in our database we have about more than 4,000 substances, more than 6,000 elementary reactions, and more than 80 kinetic mechanisms. So now we will move to the database. So here the main control panel of the database. It contains the part connected to the data, substances, processes, mechanisms. Also, it has tools like search tool, mechanism compare, and reaction analysis tool. This is for the data treatment, and the last part of controls are the controls of the database as an information system. So first I will show that the database can work locally, or like in our case, I work with the remote database, and also it contains several parts, so they can be stored and treated in different computers. So one person is working with substances, it can install the substances database on his computer, and the other people will connect to him. Or if you have some limitation in connection or space on your computer, so you can set this separate settings for the parts of your database. Okay, and the other thing, just a second. I'll put so as you can see, many users can use this database, and all of them has different rights. So we have several types of access rights. So first is just a user. He can see and use the data in the database, but cannot input or change. Another type is a contributor. So this person can insert and modify some data in the database, and he cannot modify the data of the other contributors in the database. The next level is the level of the expert. So the expert can modify all the scientific data in the database, but cannot modify the system settings. And the administrator can modify the connection settings, the access rights, and the administrator has only administrator has rights to see the log of changes. So he can see when, who, and why input some changes in the database. So this makes the storage of the data quite safe. Now we will go to the properties which are inserted in the database. First, the properties of substances. So I will tell about the controls first. So you see the formula of substances and filters of substances, so you can show not all of them, but some specific substances. You can add, remove substances, undo changes, commit changes, and actually, which is important, export substance to XML file to see the data, or copy to clipboard to insert it, for example, in chemical workbench. So the chemical workbench is opened here. I will show how to work with it a bit later. So you can import some substance again from if-done text file, from XML file, or from clipboard from some other substance. And for example, you can make summary, the traditional reference books presentation. So you have some if-done presentation of Gibbs coefficients, NASA coefficient, some electronic states, and the log of change. You see who has inserted this substance. At the right-hand side of the screen, there are the properties, so name property, thermodynamics, like what the traditional thermodynamic function, and you see the Gibbs coefficients and the two types of presentations, IFTAN and NASA. And you can see some of data may be recommended, some of them may be default. You see here was several default data, since the temperature range is different for all these three lines of data. You can present the thermodynamic data in a TPIS format, make some approximation interval, view interval, units, and can actually plot the plot some graphs of thermodynamics. The plot is adjustable. You can adjust everything, the view, the axis, and so on. So you can print and save the data. The same thing for GNAP tables. So the presentation of figures are very comfortable. So you can actually see the the history of changes. So somebody updated very so the full log of updates. So besides thermodynamics, there are substances processes, molecular processes, general electronic processes, and interaction potentials. So you see here the range is the same, so only one record is made default. And potential interaction potential types are, you see there are someone is fields, someone are not fields. So some of potential types used for different kind of substances. And since there are a lot of electronic properties, so they are different for atomic substances, for molecular, bimolecular substances, and polymolecular, polyatomic substances. So the the content of the electronic properties tab will be a little bit different for different kind of substances. So that was for substances. The second one is processes. Here you see the list of processes, the approximation time, and class of reaction. You can here also add new, edit, and show the changes records. And for convenience, you can show the processes only for some specific substances or of some specific class. You can select the class of reaction, and you will see only the reaction of a specific class. Or you can actually filter the presentation of the processes by, for example, chemical approximation. You see the approximation for chemical approximation might be Lindemann, Roy, SRI, Hebesch, collision, and so on, even user-defined one. Here you see the button of efficiency, but I will show the efficiency button, how it works in the mechanisms. You can present the data in the table interval, in the table form. So let's see other presentations like electronical type of approximation has the, you see, GILA cross-section, other cross-sections. Next one, the vibrational has Landau-Teller type of approximation. Optical has, you see, for atomic and molecular types. And the next part is mechanism database. You can see the name of mechanism, the major type of mechanism, and its description. Also, you can find here the list of phases, list of substances, and list of reactions. If you need to see the data of substances in more details, you can just click on the button, and the list of the corresponding substances will be listed here. Also, you can see the list of processes and its properties. One more important thing, that you can export and import the complete mechanisms. So you can export to the XML file, copy to clipboard. When you copy to clipboard, you can just paste it directly to the chemical workbench, or you can export mechanism to a KimKin file. So we'll just find some not very big mechanism and will show how to export mechanism. For example, in KimKin file. All right. H2. So the mechanism is imported. Here it is. All right, so you can see the name of mechanisms, the substances and the properties, the reactions and the properties. So now you can put this mechanism in actually most of scientific software, because nearly all of the kinetic software can read the KimKin type of mechanisms. So the reaction analysis is already a tool. I will show it a little bit later. And I wanted to show you the button of efficiency. So for the specific mechanism, when the list of substances is fixed, in the reactions which contains just molecule, any molecule, you can put the efficiency of some substance in these specific reactions. right. So this is all about the mechanism database. Now we will go to the tool. First tool is a search tool. Like we can find any element like C2H2 and find this substance in, for example, in processes. I think or some we have found some of them. I just cancelled the process. So you see the C2H2 is presented in many processes, like you see here a list of them, and I wanted to show you that it is actually two numerous. I will find some another element, but here I want to show that all the records here are the links, so you can just press the link and find the like process and the corresponding part of the database and see its characteristics. All right, and page 3. I hope it will be more quick. Here I wanted to show that it has found the this substance not only in the reaction database, but also it has found it in the mechanisms. Now, since in the mechanisms the figures may differ from the reference data, so you may trace the properties of the substance or reaction in different mechanisms. So you can find, for example, you can open the mechanism and see the complete set of substances and reaction in this mechanism. And also you can search this substance and substance database, for example. This is more quick. All right, so it has shown the substance in all the mechanism where it is presented, and thus you can search the complete reaction here and find the reaction. The next very useful one is the mechanism comparison. So when it is useful, when you just modify mechanisms, when you use mechanism, develop mechanism, or make some models and modify the properties of substances and the properties of elementary reactions. So you can load the mechanism from the database, for example. Again, I will select some not very big mechanisms like hydrogen oxidation mechanisms. The first one is loaded. The second one Alright, so we have loaded the mechanisms. We can put the comparison parameters, so which substances and reactions to consider similar and which will be different. And the preferred Gibbs type coefficients, which coefficients will be compared if there are both types. Alright, let's compare, and you see the comparison results. So some substances are identical and some of substances have some differences. Alright, let's plot, for example. Okay, so you see the difference in the capacity, thermal capacity, and actually we can trace some other functions. Alright, and you can see the difference in the lists of substances. Sometimes when you work with some complex substances, they may have different types of ratings, so it is written differently, but really it is the same substance. In this case, you just select these two elements and tell that these one are the same, but here I do not have the different ratings, so I can not show you this one. And this comparison of reactions, you see that right, they have, for example, different rates in the first reaction and in the second reaction. So this one are identical, this has different rates, and so on. So even if you adjust something very deeply in some coefficients, so you may not find it in the first look on the mechanisms, even if you have them printed, but the comparison side by side made by the mechanism comparison tool will reveal all of these changes. And the other buttons are made for just easier presentation of the same substances, same reactions, or different, if there are difference, if there are first mechanism only substances, and so this is made for representation. All right, and the last tool is reaction analysis. So the reaction analysis tool is made for just preliminary analysis of reaction, in which direction it will flow, what is the difference in thermodynamics potential. So you can just add some, not necessarily the reaction to be an elementary reaction, you can put some just some reaction with valid substances and check, for example, the change of the thermodynamic potential in the reaction. You can plot the changes, visualize. All right. So, and let's find some elementary reaction. Since it is connected to the database, you can select them. And let's find, for example, N2O, for example. All right, let's select this one. So you see, as it is an elementary reaction and it is presented in the database, it has not only thermodynamics coefficients for analysis and comparison, but also kinetic data which are also available. And for example, reaction constants. Let's plot them. So you see, you can using this data, you can judge the how the reaction will go, which direction of reaction you can expect at some specific conditions. So this one was the last tool, and actually I will go back to the presentation and show our contacts. So if you have some questions or the technical questions or just questions about our different or different software, I can actually, I promised you to show the chemical workbench, for example, so how they are interacting. So you see, it's just an example project, and I have some specific chemical mechanism loaded in the in our calculation, and this the data of the substances are taken from the database directly. So when you input some data in a substance, the if it is specified in the options, you see check presence in the database. So if these two options selected, then the data and the properties of substances and reactions will be read from the database. And actually you can directly load the complete chemical mechanism from the database directly. From database, or actually load from Kintech file. So we saw that we have exported the mechanism into the Kintech file. You can use that Kintech file to load to this calculation. Right now. So if you have any questions, you can send to our company, and our colleague will answer all the questions about the equipment, and actually you can take for evaluation all our software, and we can give you evaluation license for 2 weeks. Thank you for your attention.